Hello everyone. Please refer to the previous video for more details on PDA. This video includes some examples for PDA. Okay, so the example that we are going to discuss now is design a PDA for input symbols a comma b to include equal number of a's and b's. So now with the help of a stack, how can I check that the number of a's and the number of b's are to be same? So now for this particular example, there are various possibilities that I might have an A as the stack top and then I might get B as another symbol. I might have B and then an A and A with stack top, A as the input symbol and B with stack top and B with the input symbol. So in both of these cases, that is if my stack top and input symbol are same, I will do push operation. But here, if I have different symbols, I will pop. So it's basically like for a different symbol that I see, I pop, thus nullifying both. So with that logic, let me first do the PDA. So there is a comma z naught. Then I push A. If I see B comma Z naught, I push a B. With A comma A is the symbol, A is the stack top, push B and B, I again push. If I see A and B, I pop. And if I see B and an A, I pop. Now after this, all the input symbols are handled and on epsilon, and if z naught is the stack symbol, I move to the next state. I do not do any operation. I move to the final state. So in case if I reach the final state, then the string is accepted by PDA. Now let us consider one example. So consider I have 100 input, some the transitions, stack and the new state. Consider the string is ABAB. If I have the string as ABAB, so initially I'm reading an A. Z naught is the stack top. So in this case, I will read A. I am initially at state Q naught and A is what I'm reading, Z naught. The operation is push of A and I read state Q naught again. The stack will have A Z naught and I am at Q naught. Next I am reading B. So when I read B, the stack top is A and what I am reading is B. So this operation has to be applied. Q naught with B and A as the stack top. I pop. I will still be at Q naught. So when I'm popping, I will only be left with Z naught and I'm still at state Q naught. Then with B, then I'm reading an A. So again Q naught with A is what I'm reading. Z naught is the stack top. I push an A and I remain to be on Q naught. The stack will have A Z naught and I remain to be on Q naught. The next is I'm reading a B. So Q naught, B, the stack top is A. I have to pop Q naught. I am left only with Z naught. The next is on epsilon, I move to the next state which is Q1. So here Q naught epsilon with the stack top as Z naught, I do not do any operation and I reach Q1. Only Z naught is there on the stack, I read Q1. So since final state is reached, The string is accepted. Now let us take another example. Again, the same unread input, transition, stack and new state. Let me take ABB. Z0, and here I read A onto the stack. Once I read A, Q0 is my initial state. I read an A, Z0, push of A. I still remain at Q0, A, Z0, and still remain at Q0 itself. Then I'm reading a B. Q0 with stack top A. So B comma A, it's a pop. I remain at state Q0. Z0 only will be remaining. I read B. B with Z0, push B. So I get B, Z0. Now, when I read an epsilon, I am looking for Z0, but there is no Z0. So here, my final state is not reached. See, I'm expecting epsilon with Z0, but then I get epsilon with B as the stack top. So I do not reach the final state. Hence, the string is not accepted by PDA. Consider another question. Design PDA. Design PDA for A power n, B power n. So now for this, what I can do here is here there is no sequence that is mentioned, but here there is a sequence that is expected. That is all the A's first and then all the B's. So how do I handle such a question? So initially we have Q0 and we have a Q1, and then finally I am reaching my final state. So what is the logic that we use here? So the logic that we use here is I initially push all the A's, and then for every B I pop out an A, and then finally if I am left with empty stack, I reach the final state. So A with Z0 has to be pushed. A with A stack top also has to be pushed. But B with A will result in a pop. B with A will also result in a pop. So let us take an example for AABB. So I include unread input, the transitions, the stack and the new state. So AABB, here Z0 is the stack stack state, that is it will have Z0. I'm reading an A. Q0 with A as the input symbol, Z0 as the stack top, push of A, comma, I still remain at Q0 itself. So it will have A Z0, I remain at Q0. I'm reading an A now. Q0 with A as the stack top, again push of A, comma, Q0. So A Z0. Now I'm reading a B. Q0 with B and A as the stack top, I perform a pop and I reach state Q1. I get A Z0. Again, I'm reading this B. Q0 with B and A as the stack top, again a pop, I remain at state Q1, Z0 is alone there. And then epsilon, so Q1 with epsilon and Z0 as the stack top, no operation to be done, I reach Q2. Z0 remains and here I reach Q2. Since the final state is reached, I tell that the string is accepted by PDA. Let us consider one more example, WWR. So, design PDA for WWR. This means the string and then its reversal, something like 0110. So if you take this, this is W and this is WR. So how do I check for such a string? So for this, the diagram will look like, so the idea is I push in everything in the first half, and then if I see the similar symbol, I pop. Okay. So like for example, if there is 101, 1, or okay, let me take the example as 110, the reversal will be 011. So here I push in 110 on the stack, and if I see a 0 again, then I pop it. Now I will see 1 and a 1, pop. If I see a 1 and a 1, I again pop, resulting finally, if the stack doesn't have anything, I will reach the final state. So initially everything has to be pushed in. So 0 with Z0, push of 0, 0, 1 with Z0, push of 1. Now 0 can be before a 0 also. I can have 0, 0, then also push of 0. 0 can be after a 1 also. So again push of 0. 1 similarly can be after a 1. So 1 and 1 will also give me push of 1. And the last one, if I get 1 with a 0, that will also be push of 1. Here with epsilon, that is, once I reach the first half is done, then I will include an epsilon. Epsilon with 0, no operation. It's only to move to the next state. Epsilon with 1, also no operation, only to move to the next state. Epsilon with Z0 also, there is no operation. Now, how do I pop? I will pop if I see similar symbol. For 0 also, I will pop if I see similar symbol. So all these transitions are for Q0. These transitions are for this, moving from Q0 to Q1. Q1 on itself gives me this. Q1 with Q2 gives me this. So I will take one example. Let the word be 110011. So I have 100 input, the transition, stack, and the new state. Okay. So I have 110011. Z0 is the stack top. So initially I'm reading a 1. Z0 is the stack top. So it is this transition. Q0 with 1 Z0. I push a 1 again remaining on Q0 itself. So I will get 1 Z0. Here we are actually supposed to be considering an epsilon. That is, this is my W and this is my WR. So here I will consider an epsilon. So I'm reading a 1 this time. So I'm reading a 1. So Q naught with 1 and 1 as the stack top, I push a 1. So I will get 1 1 Z naught. Then here also we can consider an epsilon. Here also we can consider an epsilon. Now I am reading 0. Q naught with 0 with 1 as the stack top, I push a 0. So I will get 0 1 1 Z naught. Now with epsilon I move to the next state. Q naught with epsilon comma 0 is the stack top, no operation, just move to the next state. Now I am reading a 0. Now 0, if 0 is the stack top, I pop. So Q1 with 0 and 0 is the stack top, so I pop. I get 1 1 Z naught. Similarly 1, Q1 here, 1 is the stack top, I pop. So I get 1 as the stack top. Nothing, epsilon only. Q1 1 1 as the stack top, pop. So I am left only with Z naught. And here Q1 with epsilon Z naught, I do not do any operation, it just takes me to my final state. And I write the conclusion that since final state it is reached, the string is accepted by PDA. So here after W, introduce an epsilon here and just continue that. Thank you.